Hey guys, it's Mrs. Shevchuk, and today we are going to sum up our learning from yesterday's board work with factoring special products. Our goal today is that we are able to factor binomials that are differences of squares and factor trinomials that are perfect squares. So these are 4 problems that came from yesterday's board work, and a lot of groups realized pretty quickly that instead of writing out all of this work for these problems, they were noticing some shortcuts. And so today we're going to take that, the learning that you did yesterday and put it into our notebook so that we have something concrete to work with going forward. Please add a page in your composition notebook called Factoring Special Products. This comes from lesson 10-7, and I would recommend that you follow along on page 591 in your textbook just to make sure that you have all the information that you need, and you can always add additional examples if needed. Push play once you have this set up. All right, the first special product we're going to work with is the difference of squares. All right, so to write this in symbols, what we're going to say is when we have something like a squared minus b squared, so we're subtracting 2 perfect squares, that's going to be equal to a plus b times a minus b. Or you could flip those around and say a minus b times a plus b. So yesterday, some of the examples we saw were more basic, like x squared, minus 36. And so we can factor this difference of squares by taking the square root of x squared, which is just x, right? And then the square root of 36, which is 6. And then we add 1 and we subtract 1. And you could check this by foiling as well, but this one's kind of straightforward. Sometimes it'll look a little bit more complicated, but the steps will be the same. So let's say we have 25x squared minus 64y squared. And I'd like you to copy this one down in your notebook as well, so you have some examples here. All right, so if I am going to be trying to identify my a and my b in this, my a is going to be 5x, because the square root of 25x squared is 5x. And my b is going to be the square root of 64y squared, which is 8y. So think of this as a, think of this as your b, and then we're going to do a plus b and a minus b. So 5x plus 8y would be my a plus b. 5x minus 8y would be my minus b. And again, we can always check it by foiling. We can do first 5x times 5x is 25x squared, and 5x times negative 8y is negative 40xy, and then we have positive 40xy, and then negative 64y squared. So it works out. All right, we're going to add a second subset in on this note page now called factoring perfect square trinomials. Push play once you have this recorded. When we square binomials like a plus b squared, or if we do a minus b squared, what results are special products called perfect square trinomials. And so for it to be, for a trinomial to be factorable as a perfect square, we have to have 3 things that must be true. And I want you to get these in your notebooks right now. First, the first term has to be a perfect square. Also, the last term has to be a perfect square. And finally, the middle term is 2 times the product of the square roots of the first and the last terms. So let's sum this up in symbols to make sense of it. Be sure to get this in your notes, as this is going to be our pattern for factoring perfect squared trinomials. All right, let's do an example in our notebook. So go ahead and copy this down and then push play when you're ready. All right, so we're going to determine whether this expression is a perfect square trinomial. And first, we're going to check and see, does our first term contain the perfect square? And yes, we can find the square root of 36x squared, and that is just 6x, so that one works. Then we want to check and see, is our last term a perfect square? Well, yeah, the square root of 25 is just 5. So that is also true. And then finally, is our middle term 2 times the product of our square roots of our first and last? Well, let's think about that. What's 6x times 5? Well, that's 30x. And then is this going to be double that? Yeah, we get 60x here. And so that is going to work as well. So that means we can go ahead and factor this out. This will be a perfect square trinomial. I notice right now that since there's subtraction going on here, I'm going to be using this second set of rules here. And so we're going to use a squared minus 2ab plus b squared. That's the form it takes. So in this situation, my a is going to be 6x. And my b is going to be 5. And I'm going to do 6x minus 5 squared. And then let's check and make sure that we have, that if we, multiply this forward, we end up back where we started. And so we get 36x squared minus 30x plus 25. So 36x squared minus 60x plus 25. And that's exactly where we started. So we have factored this one completely. Let's do one more for practice. All right, first you want to determine whether the trinomial is a perfect square trinomial. And if it is, go ahead and factor it. Push play when you're ready to check your work. All right, I've determined that yes, this does in fact meet the criteria, so now let's go ahead and factor it. Push play when you're done. All right, when I factored it out, I got 3n plus 5 squared, and then I used the generic rectangle over here to check it and make sure that it worked out. Thanks for watching. Sometimes you'll see examples where you're going to have to factor more than once. You can find this one at the top of page 592, and it looks like this. We've got x to the 4th minus 256. All right, so what we want to do is write this in the form a squared minus b squared. And so when I do that, I'm noticing that this is the same as x squared minus, and then the square root of 256 is 16. So I'm going to say this is the same as 16 squared. And what this does, you guys, is it allows me to think of this as my a and this term as my b. And then we're going to do a squared minus b squared. And so what that looks like is I'm going to take x squared, that's my a, minus 16. There's my a minus b. And then we're going to do times a plus b. So x squared plus 16. All right, and then I'm looking to see if I can factor this another time. This first one, x squared minus 16, that's a difference of squares. So I can take this and say that's the same as x plus 4 and x minus 4. And then there's nothing I can do here to make that, there's no common factors I can divide out, so that just stays as x squared plus 16. And so this is factored completely.